Good morning, everyone. Well, it's at least morning here. It's 8 a.m. in the UK. Hope everyone's enjoying the super springtime weather here. If you're one of our Estonian listeners, I gather it's still pretty chilly, but spring is definitely on its way. We often do these podcasts focusing around a certain topic that may be kind of in the mainstream media, and the topic of energy, and especially nuclear energy, has been on everyone's lips recently. Here in the UK, energy prices are going through the roof. An average family is going to be expected to pay an extra £800 to £1,000 a year for their energy at the moment. And of course, nuclear energy has been on people's lips due to what's going on in Ukraine. And I think there's a general lack of understanding about how it all works, but let's see if we can open a window onto some of that. So look, I'm really pleased to be joined by Kallemets, CEO of Fermi Energia, who is, just a disclaimer, Fermi are listed on the Funderbeam exchange, but this isn't really a massive push for Fermi. But Kalev, how are you?
Very fine, very happy.
Good. Just for most people in Estonia are going to be aware of you and your career and everything. Just for those outside who may not have read anything about you before, can you just give us a little career background, the elevator life story?
Right. Yeah. So I've studied economics and energy economics. Worked in private industry in a major energy company in Estonia. Then I've been a shortly member of parliament, and also worked in government. So this is common in Estonia, that people are in different sectors, that we do have a small population, and therefore some people do many roles in life. And I've had the luck of having multiple perspectives on energy. And I realized through my PhD studies that the oil shale industry and oil shale power generation, which is the mainstay, has been for 100 years, is coming to an end. Not only because of the decarbonization effort, but also because it's inherent capital intensity. And so I saw that there is a structural or a strategic stiffness in this whole ecosystem, and I realized that this comes to an end sooner than many people predicted. And I realized also that the SMRs are a technology that has to be pursued, and my life experiences brought me to realization that this is something that needs to be pursued with full seriousness.
Okay, so let's just put things into context. An SMR is a small modular reactor, which is essentially, for anyone listening, a mini nuclear power station constructed largely in one place and then delivered kind of in one go. I was just to put again into a bit of context, Rolls-Royce would suggest they're a producer or at least a developer of SMRs. That an SMR is around the size of 2 football pitches, and one reactor can power around 1 million homes for about a year, something like that. Is that right?
About the ballpark. For Rolls-Royce, we are looking at another technology. We have an outstanding MOU with Rolls-Royce, and we are very happy on their good performance on funding and moving to the licensing procedures. But we are looking also at the American Beaver X300, and this is moving also even in rapid space, and it's even smaller, so 300 megawatt unit, and we are rooting for both of them.
So the thing I guess most casual listeners to this podcast who may be kind of interested in investing in the rest, most people don't really understand how a nuclear power station, the old school nuclear power station works, let alone how you condense one down into something the size of a football pitch. Or so could you give us the quick overview of how nuclear energy works compared to oil, gas, and so on and so forth? Yeah,
well, we have been burning stuff for millennia, and now we're burning fossil fuels, which emits copious amounts of carbon emissions, but also methane, which are harming our planet in a very long perspective. We have to stop that. And we have decided, I mean, the civilized world at least, that we will stop that as quickly as possible by 2050, and is the EU commitment. And so with nuclear, what you have is the splitting of the atom and thereby generating heat. And the fuel elements, which are in metallic rods, they heat up to 500 degrees and they make the water hot to steam it, and the steam spins the steam turbine, and then you have a generator through the shaft, and you have power in very large volume. And it's amazing that the energy density of nuclear fuel is 6 million times higher than that of fossil fuels, where you have oxidation, which oxidation basically is electron exchange between the molecules. So chemical forces are in play, but nuclear forces, because the Albert Einstein really was right and is right that the E equals mc squared, and that all the mass is in the nucleus of every atom, then you know the force, just the raw energy is so much more denser, and therefore it's a far superior technology compared to chemical burning.
So traditionally, what, you know, I guess people envisage nuclear power stations as being expensive, extremely complicated to build. Well, I remember here in the UK a while ago, we had outsourced contracts to France and other places and China, and the whole thing's actually quite political, presumably because there's a lot of money involved. Is this the kind of reason why more nuclear power stations have not been built around Europe, or is it something else politically that holds people back?
You're absolutely right. I think Estonian experience is that smaller is better. Smaller is more nimble, more efficient sometimes, and less complicated. And it's true also for nuclear. With smaller energy in the reactor, you're much more able to safely manage the decay heat, which is the reality when you shut down the reactor. And so therefore you are able to provide much higher safety, but also making the construction itself less complicated. And also money wise, 10 billion is 10 times less than 1 billion, and raising 1 billion is enormously less complicated than raising 10 billion. And also when your construction time is 10 years, then it is enormously more complicated than having construction time of 2 years. So there's the very big difference, really big difference. And people do not appreciate really sometimes how exponentially more scalable technology is if it becomes simpler.
Yeah, and I was interested when I was doing my reading on SMRs, is that like so many things that probably wouldn't have been possible X number of years ago, and we're really only even at the beginning of this technology kind of phase, and presumably we're going to be able to get these things smaller and more compact and more efficient, and I guess this is the future. So I mean, do you see a time, or maybe you wish for a time, where rather than big nuclear power stations dominating like 1 or 2 areas, that we power individual cities with small reactors?
Absolutely. I do believe that small modular reactors are inherently, from first principles on what I described, more economical, more deployable, faster, more scalable, reaching out to more customers, and also being closer to the customers. So what we see is the target of power generation of cost like 50 to 55 euros, where your load factor is 95%. So 95% of the year you're generating power independent of the weather. So fundamentally, fundamentally, even if the LCOE of wind or solar is similar, their capacity factor is 25% or 10% in England. So therefore, I mean, it does not, it's comparing like bicycle to a car. You're in the winter with snow, bicycle is just a nice asset in home. So it's the same with solar. So inherently, I see SMRs going to be increasingly the dominant source of energy in the West.
Yeah, it's really interesting actually, because again, I'm no expert in this for sure, but the way that the power grid works is another interesting thing. And people pulling power seemingly from places that are very, very far away. So you may have a power station 300-400 miles away, and somehow that pulls through the grid, and then someone's selling it at various points. And so by the time it gets to the end user, this thing's super expensive. Actually, the thought of having a small reactor that concentrates geographically on areas, presumably that brings down energy cost as well.
Absolutely. And what we are looking forward is that at least more than half of our power generation is not to the market at all. We are interested in closing long-term 15-year PPAs at 55 euros per megawatt hour, so that customers, industrial or the state or the municipalities or hospitals or universities, they would have high confidence for 15 years what is their energy cost. And we know that at least in the Baltic market, and also looking at the Western European market, we are way more superior compared to purchasing it on the market, or where you obviously have a huge amount of fossil fuel that is balancing the grid, and where your grid costs are also dumped into the customer. So we believe that this product is fundamentally, first principles on, far superior to any other energy technology.
Yeah, it sounds cool in principle for sure. So let's just agree that we like it and it's a great thing to do. Who not necessarily in Estonia or Europe, who's the enemy of the SMRs? Who doesn't want these?
Obviously, the fossil fuel industry is the one that feels threatened, and they would like to continue that a nice slogan that they had, that they are a perfect partner to renewables. And I don't think that the slogan has played so well in the light of Russian aggression against Ukraine. So and we have to also realize energy is never just business. What our German friends try to say about the Nord Stream 2, it's always about the political choice as well. What kind of friends do you have? What kind of allies do you have? What kind of future do you have? And what kind of a society do you have? Do you have an open and honest society, or you have fossil fuel driven shady deals with shady suppliers? Even without Russia, the suppliers of fossil fuels are let's say, not the most transparent, not necessarily the Western transparency and democratic values-driven companies, so or suppliers. So I think this is what we need to abandon as quickly as possible, and I'm extremely pleased that EU and United Kingdom and United States are taking measures to abandon and terminate energy imports in any source of and manner from Russian Federation by 2027. And obviously this generates in short term higher price environment where investments into clean energy are very substantially asked by the market and funded by the market.
Yeah, on that note of not specifically Russia, but of course it's in everyone's minds at the moment. I feel that with energy and energy prices, the end consumer is probably it's the area they have the least choice, the least influence, and the least control, if you like, over there, because here in the UK at least, I don't even know who my energy supplier is, but one of the big guys. But it's sold on a million times down the line. But there's absolutely nothing I can do to, you know, they tell me to use my stuff less. So rather than them giving me good pricing to encourage me to do things, they tell me, well, turn off the TV more. And that's a really strange mindset for any other product.
Absolutely. And this is heartbreak for many European customers in all nations. And that is so bad. And what we try really with Fermi Energia is to bring competition to that space. So that somehow energy has been most oligopolistic, very limited competition, kind of some so-called big boys, which are actually bold, gray hair, like brown suit, boring, kind of shady figures business. We need to develop that into more exciting energy or technology driven, and really importantly, what we are really happy about Funderbeam is also that it's driven by retail investors, that the retail investors are educated, engaged, and are able to fund and support with their action, with their knowledge, and with their engagement, companies that deliver better product to the people.
Yeah,
better priced product, cleaner, and where the companies are responsible, are transparent, and you know, engaging with their shareholders.
Yeah, I mean that's absolutely right. It's also that, you know, back to the political thing. You know, you often feel that, you know, of course, political actions have a knockdown effect on many things price-wise. Like, but again, the energy one is like one we can't do anything about at all. So something happens, or a deal's done between one state and another that affects you in this way, and you just got to sort of sit there and go, well, you know, I can't not use my washing machine, so you know, I need to carry on. I just think that what we're talking about here is pushing more and more towards privatization of things, and of course that's happened here. Maybe it worked, maybe it didn't. There are lots of places around the world where privatization for energy would never be an option. So do you see that governments or monopolistic environments will embrace the idea of small reactors as much as energy entrepreneurs and, as you say, people that might want to make a difference in the world?
Look, I don't think that Elon Musk was immediately welcomed by the car industry, was immediately welcomed even by the governments, or was recognized that what kind of impact it might have. So I see that the companies like us, we are that are developing SMRs, and there are quite a few already in Europe. In Sweden, there is Scanful Next that announced like publicly their work last week. In Poland, there's Synthos trying to develop SMRs in Poland in significant numbers, and there are a few others. That if we are able to demonstrate to our customers, to our investors, that we are providing superior service to the customers, to the investors, and in terms of return as well, then I do believe that investors, the capital, will move to those companies to scale their power generation, to provide superior technology to the customers, and therefore I think that some markets, maybe France or so, that might be, you know, quite closed, or even Germany that is now abandoning nuclear energy, they will obviously observe that you know, neighbors next door, or some nations or companies are able to provide just more superior service, more superior, lower cost, cleaner, more sustainable, and doing it in a transparent and open manner. And that is what we are absolutely committed to do with our team and with our shareholders.
Why do countries abandon plans for nuclear? What, you know, is it purely a money thing, or again, are we talking about politics and business crossing over into the murky dark world?
Well, in a case of democracies, it's less murky. So like I said, energy will be always politics, and Estonia has made our choice that we are members of NATO and the European Union, and we cherish those alliances. We consider them fundamentally important to our democratic values and the sovereignty of our nation, and therefore enhancing those alliances with United Kingdom, Canada, United States, and France through nuclear energy and the fuel chain of nuclear energy and the know-how sharing and cooperation. This is absolutely aligned with the national interest of Estonia and other nations in the Central Eastern Europe as well. So this is only correct and right that the free nations do cooperate, and we absolutely are doing that. We are very pleased that we have already shareholders from United States and Sweden and Belgium, and also internationally retail investors. So we're open in that regard, and we're committed to engage our Canadian and other partners in good cooperation. We're very happy that with the cooperation we have with the Canadian largest power generation company, OPG, that is deploying the first PV reactor 100 in close to Toronto. So the cooperation element will always be there.
So you mentioned earlier about the guy with the brown suit and the old, slightly aging and maybe not the most dynamic. Why isn't energy sexy, really? Like, it never, I mean, can be, I suppose. I think some of the sustainable stuff, wind turbines, hydro, you know, but it's not really, you know, there should be a tech scene behind this. Like, there should be like an app that I can look at and see my energy usage and decide to turn off elements, you know what I mean? Like, yeah, it's like there should be a guy or girl somewhere that's really good at coding that comes up with some like a way of making energy more accessible. Maybe that's it. But have you noticed that? I mean, we're probably roughly the same.
In Estonia, all the customers are on the self-reading automated system. It's all data driven. There are companies, multiple companies providing the power management services, so that you're loading your car in the or the heat pump is activated at the cheapest hours. So this is all happening in Estonia, at least. I know that in Germany there are discussion at only 10% of the readers are self-reading and automated, so still mechanical kind of. And unfortunately, some really jurisdictions are rather poor in catching up with the technology development. But this is here the opportunity for certain companies, certain jurisdictions, whether you are able to manage and take advantage of improved technology and move forward and be innovator, or you're just lagging in the 20th century. And I believe that companies moving forward, innovating faster than others, I believe that Elon Musk is right. And if you are innovating faster than others, you are having a definite strong competitive advantage. And the companies that are not innovating, or the countries, there will be lagging behind.
Yeah, I think also maybe culturally in a lot of places, it's not like a natural career path thought to go into the energy sector. Like, I don't recall ever, you know, during my studying or whatever, ever think about going into energy. Like, it's almost this big thing over there that just runs itself.
And you see how wrong that is, because right now this is a service that the society really needs, because the prices are high, and this is the primary source of the carbon emissions. We have to also transportation. We have to decarbonize 100%. So we need to provide 2 times more primary energy from nuclear and renewables to actually ditch fossils. And this is a huge social and talent and capital pooling exercise that never has been done in the humanity before. So only maybe comparison is when we moved away from the whale oil to kerosene. So it's the same thing. the whales were, dying out, and we needed to start using kerosene. But this was what, 150 years ago. So now we are where the population is vastly more larger. So the challenge is tremendous, and the amount of energy, primary energy that has to be generated is thousands of terawatt hours annually. And so one unit of SMR that we are aiming for is able to generate 2.5 terawatt hours. So we need thousands of those units deployed in Europe, in Asia, in Australia, in America, South and North. So to decarbonize really the world.
Yeah, and some of the stuff you just touched on there is getting into quite the theoretical space, which is interesting. So I wanted to just, now we can talk a bit like some crazy stuff. So I heard something the other day, and I can't remember the exact percentage, but it was a really interesting quote that X percent, I think it was above 20% of the world's energy is spent trying to overcome friction. As a society, we have lots of things and we use lots of objects and things in our daily lives, and all of the energy usage is to overcome friction. So cars, whatever. And then I started reading up about not frictionless society, because it's impossible, but forms of transport like Hyperloop and all the rest that don't rely or don't need to overcome friction. And it then started me thinking about the amount of energy we use on things we don't really need. And then obviously the parts of the world where people and fully in the spotlight right now don't have the energy for things they desperately need. Where do you think that SMRs can fit in to find a way of making sure there's always energy in places that at the moment don't have it? And how would one pay for that? I mean, I've worked all over Africa, and energy is a thing. Of course, solar's big, but let's be honest, it doesn't work it doesn't work for the needs of everyone. But how can we encourage and skill up a workforce to be able to build and maintain small reactors in places that desperately need it? It's all very well us saying, oh, it's better for our consumers to have us cheaper energy, but what about places where they don't have the energy in the first place?
If you don't mind, I do not have answers to all questions. But
no.
The one important element when it comes to superior technology like electrical vehicles, even mobile phones, or SMRs, or let's say rocket engines, and like a really advanced technology like IT and electronics as well, it requires strong institutions. It requires that there is education and low corruption, well-functioning rule of law, and essentially, if we do want Africa to be able to utilize advanced technology in full scale, as we do enjoy in the West, fundamentally, they do have to desire, and they do have to work and get educated and deploy those fundamental social institutions as we have. And unless they do that, it is impossible to deploy advanced technology in scale that benefits to the society. This is the truth. That you can't, drop advanced technology in a place to the desert or bushes and hope that it will be utilized to its actual potential. It doesn't happen.
Well, that's true. And I, in a previous life, I worked on a big carbon credit-based project in Rwanda, and giving advanced cook stoves and water filters to 250,000 homes. And the biggest blocker to the whole thing was the education, because if you give someone a water filter and they've been drinking water from a lake for 2,000 years, this big blue box in the corner means nothing. And if anything, it's quite off-putting. And if they've been cooking on 3 stone fires for centuries, and you suddenly give them a rocket stove, the first thing that they generally do is go and try and sell the stove, because what do we need it for? We've been cooking on it's. But and so the education piece.
Talking about SMRs is really stretched from cooking stove, right?
Absolutely, but the principle of education coming first is really important, because as you say, you can't just airdrop the technology in and assume that it's going to be handled in the right way, let alone and therefore have the benefits. Just the last thing before we let you go, on the SMRs specifically, I mentioned at the beginning of the recording that they're kind of obviously modular in design, but I mean, and I think when I was reading about the Rolls-Royce, they said 90% of the reactor is created in one place, which is pretty astonishing. How do these things get built and shipped? I mean, they don't sound very big, so presumably you don't have the huge amount of time for build and construction that you would traditionally. But is the cost of building them higher because they're kind of small, or is this part of the kind of cost-saving benefit that it's just easier to make one?
They're certainly easier than the large reactors. The amount of steel and concrete per megawatt hour for the units that we are looking at is 2 times lower per megawatt. So, but let's not kid ourselves. Still, the reactor unit itself is a 485-ton unit. The steam generator and the steam turbine and the generator are also like 250-ton, quite substantial mechanisms. But what is really interesting about the SMRs is the localization, that you are able to manufacture more components closer to the site compared to large units, where really the supply chain is really narrow globally. The amount of certain valves, certain pumps, the number of suppliers is really limited. So, and this is one of the big problems that we have seen with Hinkley Point, with Flamanville and Olkiluoto as well. And also those construction projects, really, they are so massive. It's 4,400 workers need to be, in a like orchestrated, really in a chain reaction in a really well manner. Whereas our project, we're looking maximum workers on site 400. So there's a 10 times difference, and 10 times difference is actually in management wise, it's exponentially higher, not linearly. So, and managing that complexity and complexity management is really hard. So, and making things simpler, like we see with SpaceX, like we see with electrical vehicles, making things simpler fundamentally is fundamentally important. It's one of the first principles of things.
Yep, and I think any founders and entrepreneurs listening all know that making things simpler is is how we get things done. Kalev, thanks very much. I'll be in Tallinn next week, so maybe we'll come and say hi. But thanks for joining us. What are your plans for the rest of the week?
What?
I said, what are your plans for the rest of the week before we...
Tomorrow we will have a quarterly founders meeting, which is one of the fundamental ways how our company works. Our 7 founders are coming together to make plans for next 4 quarters, and we're reviewing our decisions and also planning many important elements and making very important decisions.
Great. Well, look, thanks for joining us, listeners. Fermi Energia is listed on the Funderbeam exchange, but trading is not always open. There's trading windows. You can read all about it on the website. Capital is at risk if you're looking at investments, I must say that. And Kalev, thanks very much for joining us. We'll see you soon.
Yeah, thank you very much. Bye.